Hello students. Today in this video, this is part 2 of solution of PYQ of HS final examination under Assam Higher Secondary Education Council. Today we're gonna find capacitance of a parallel plate capacitor or condenser. This was asked in 2014. Okay, this is this topic is from second chapter of physics, class 12, electrostatic potential and capacitance, right? So before we start, please subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you. Okay, and if you want to follow me on Insta, this is my Insta ID, Ozalakhyajit, OZHALAKHYAJIT 123. This is my Insta ID, so follow me on Insta, right? So now let's take the question. So here is the question: deduce an expression for the capacity of a parallel plate capacitor or condenser. This was asked in HS final examination 2014 under Assam Higher Secondary Education Council. Okay, so now let me write the answer to this question. Okay, so first let me consider a parallel plate capacitor. Okay, so these are the two plates of a parallel plate capacitor, right? And here positive Q charge is given, and here negative, as a result, negative Q charge is induced on this plate. Okay, right? So let me write it, give you positive charge and here negative charge. Okay, and as a result there will be an electric field in this direction from positive to negative. This is the electric field. Okay, and charge density on this plate is plus sigma and on this plate is minus sigma, and these two plates are separated by a distance d. Okay, these two plates are separated by a distance d. This is plate 1 and this is plate 2. Just let me write here. This is plate 1 and this is plate 2. Okay. Actually what happens here, you can see, if you consider these two are the plates, let me consider this way. When you give positive charge to this plate, right, then the face of this plate 2, which is facing towards this plate 1, right, that will be induced, there will be negative charge will be induced on that face which is facing towards this plate. Okay, and on the other side there will be positive charge, and to neutralize it, this plate is grounded, and as a result electrons will come up to neutralize these positive charges, and that's why this plate becomes negative. Okay, so that is what happens here. Okay, so then when it is grounded, then this plate becomes negatively charged. Okay, so hope you have understood this. So let me explain again. This is a plate, right? It has two faces. This is face 1 facing towards this side and towards that side. So if you give positive charge to this plate, then this face which is facing towards this plate will be negatively charged. Okay, the negative charge will be induced here, and if negative charge induced towards this side, then the other side will be positively charged. Okay, positive charge will be induced, and to make this plate completely negatively charged, so we have grounded this, and electrons comes up to this plate and neutralize these positive charges. Okay, and that's why this plate 2 becomes negatively charged, right? So hope you have understood this now. So here you see, let me first write what I have considered here. Okay. So here what we have considered, we have supposed a parallel plate capacitor or condenser consisting two parallel plates 1 and 2 separated by a distance small d. Area of each plate is A, and when positive Q charge is given to the plate 1, then negative Q charge is induced on the plate 2. Okay, nearer face of the plate 2, right? And we have taken positive and negative sigma be the surface charge densities of the plates 1 and 2 respectively. where sigma is given by Q by A. Okay, charge per unit area, right? So now let me copy this diagram and let me go to a new slide. Okay, so just pause the video and note it down. Okay, so here is the diagram. Let me draw it again here. This is the diagram we have drawn. Okay, now what we're gonna do here, we have taken sigma. Let me write this again. Q by sigma is Q by. Now you see electric field between these two plates. What will be the electric field? We know that electric field at a point due to a charge C is given by sigma by 2 epsilon. Okay, sigma by 2 epsilon, right? So here we have two plates. So what will be the electric field between these two plates? So due to one plate, this is the electric field, right? So due to two plates, 2 into sigma 2 by epsilon naught. So 2 gone, we're gonna get sigma by epsilon naught, right? So that's what we're gonna get. So now therefore electric field between the two plates that is given by E is equal to sigma by epsilon naught. Okay, and sigma is nothing but Q by A, so we're going to use that expression here. So Q by A epsilon naught, right? So this is suppose equation number 1. So using equation number 1, right? So now, so epsilon naught is electrical permittivity, right? Of free space. Now you see, we also know the relation between electric field and potential is, we know that electric field E is negative, gradient of V, dV by dr. So that's what we know, minus derivative of V with respect to R. That's so if V is the potential here, if V is the potential, difference between the two plates, between the two plates, right? Between the two plates, then you see from this what we can say, potential difference dV is equal to, if you take the magnitude only, then we can ignore this negative sign. dV is equal to E into dr. dr represents distance here, dV is the potential difference. So that's why what we're gonna get, here you see the distance between these two plates is d, and here you see electric field is E, so potential difference here V is given by E into d, sorry not d, here instead of dr we have small d. Okay, right? Because here you see from this expression we're gonna get dV is equal to, magnitude of dV is equal to E into dr. That's what we're gonna get, right? So instead of dr we have d now. Okay, small d. So hope you have understood this. So if that is the case, then what we can write, so let me take this as equation number 2. This is equation number 2. So if we use equation number 2 here, what we're gonna get, instead of E we're gonna put this Q by A epsilon naught, Q by A epsilon naught into D. That's what we're gonna have, right? So now using equation number 2, right? So now capacitance, we know that capacitance of parallel plate capacitor, capacitance of a parallel plate capacitor is given by, according to the definition, is C is equal to Q by V. Now let us take this as equation number 3. This is equation number 3. Okay, so now we're gonna use this equation number 3 in this. Okay, so here you see, from here what we can write, that you see, from this expression V is equal to Q d by, from equation number 3 what we have got, V is equal to Q d by A epsilon naught, right? Let us replace this V with this by this value. Okay, so let me go to the new slide. Let me take a new slide. Let me copy this last two expressions. So here you see, so this is what we have got, right? So now this was nothing but equation number 3, right? So this was what, capacitance of the parallel plate capacitor. Now you see, if you go back to the previous slide, if you have written up to this, then you can continue from this step. Okay, just as I have changed the slide, so that's why I have written again these 2 steps. Okay, you don't need to repeat this. So now here you see, C is equal to Q, instead of V we're gonna put Q d by A epsilon naught. This value we have used here. Okay, using 3, then Q cancels, so C is equal to A epsilon naught by D. This is the required expression. Okay, this is the required expression. This is the required expression. So hope you have understood. Thank you for watching. See you in the next video. Okay, stay connected. If you like my videos, and if you like my videos, then hit the thumbs up button. Also share with your friends. Inspire me to create new contents for you. Okay, hit the bell icon so that you get notified when new video will be uploaded. Bye bye.